one little bit of news that recently dropped. There was an announcement that in China, the state organizations are going to be adopting RISC-V, or at least exploring it. Tell us a little bit about that.
Well, I can't speak to other governments, but we are seeing exponential growth of RISC-V around the world. In last year, we saw more than 25% growth year over year in our membership. We're more than 4,300 members now, which is probably even up a little from our press release because we got last month's close. But we're seeing this diversity of interest in RISC-V that's really profound. We've got about a third of our members in North America, Europe, and APAC, pretty evenly distributed. And the really cool thing is, I've been saying that for 5 years. It hasn't changed. The level of interest is continuing to skyrocket evenly and profoundly around the world. And we're adding into that new areas. So the Ministry of Brazil has just signed agreements with the European Union and with working out things with Spain and Portugal to do even more for Latin America and Spanish-speaking countries. So the Ministry of Brazil has joined RISC-V and sit on our board now. And that's great because when it comes to kind of that government support, that federal support of RISC-V, it's really important. And whether I'm talking to the European Union on the funds and grants that are going on for RISC-V, or countries like Brazil or India that are investing in RISC-V, the main thing here is invest local, shore up that local economy, engage in the digital economy, teach computer science in all your universities, and do it on RISC-V rather than those other architectures. And what you're going to do is engage then in the global economy. Don't do it for yourself, do it in a global way. And that's why RISC-V as a standard is so important. Okay, I've been talking a lot. Your turn.
Well, look, I look forward, with this news about Brazil, I look forward to the RISC-V Carnival standard. That should be fun. What are some of the industries that are driving all of this growth? I mean, I know that we've been talking a lot about automotive, which is exciting and cool, but what are some of your other favorites?
So yes, industry's driving, like automotive.
Hey,
nice. I didn't miss that. So embedded, this is kind of where it started for RISC-V, and we've started to really move up the compute spectrum into even more robust or performant workloads. So embedded is all about lightweight, low power, portable, very single focus design, and that has been an incredible start, and we're starting to see that grow into mobile. We've seen a lot with Android coming onto the systems or onto RISC-V for application processing, but that's not the only processor in your phone.
Yeah.
You also have Wi-Fi, Bluetooth, all the other pieces and parts of your phone that there's a lot of area there that everyone can take advantage of. You move from there into, tablets, laptops. We've got a couple of those here at the show. You move from there into data center and the workloads that are looking to come onto RISC-V in the data center is already pretty profound. You look at and hear from companies who have massive data center footprints. Meta talks a lot about RISC-V these days, right? You hear from other hyperscalers that have incorporated RISC-V into their designs. This is where innovation comes together with volume, and it's RISC-V at scale.
So RISC-V is hockey sticking, it seems like, and a whole industry that's been threatening to do that for a long time and is near and dear to my heart is IoT. So they're obviously very interested in low power, edge devices, that kind of thing. Are you seeing those companies in those spaces getting on board with RISC-V too?
So RISC-V is sort of a catalyst at the right time, right place for things like AI and acceleration and chip in everything. Somebody earlier today was saying there's going to be a chip on every cucumber in the supermarket, and I was like, whoa.
Delicious.
Yes, right. Goes well in a salad. So yeah, you do have that profound opportunity, but before RISC-V, you had very few people or companies who could engage in that opportunity because there were too many barriers to entry. RISC-V, it's, anyone can do with it what they wish. So that's why you have more design houses on RISC-V now than any other architecture in history.
So let's get evangelical here. Ladies and gentlemen, boys and girls, we're going to get evangelical. Nobody gets that because we're all in Germany, but that's fine. Let's talk about open source. Because, look, RISC-V is embedded in open source and is clearly a driving force there. I think open source is critical to success in embedded in almost every computing space. And there's a place for the walled garden, there's a place for proprietary, but I think open source is where a lot of innovation happens. And I know that the RISC-V is really supporting a lot of that innovation. So I want to hear about some of the open source projects that you're excited about that you've been seeing happen.
So I love open source, near and dear to my heart, but let's not get too confused. RISC-V is not open source. RISC-V is a standard.
Sure.
And the difference here is that you take a standard and you freeze it for the test of time, right? Because if you decide to go off and do your own special Bluetooth or your own special, name your favorite hardware interconnect standard, you're all by yourself. Right? You don't want to be off in those weeds. So a global standard is something that you collaborate on, in our case, openly collaborate on, and then freeze it for the test of time. And that's a really cool thing.
Yeah.
And it takes time and it takes diligence and it takes a lot of interpersonal dialogue with one another in the community that we all come to agree on things, right? And that's hard work, and we're doing that hard work. We support then open collaboration in open source software where you can apply patches. You can invent something over the weekend and put it up into a repo, right?
Yeah.
And so yes, we absolutely support and honor the open source software community as well. In fact, getting all of those distros to run on RISC-V, getting all the applications to say, you know what, I run on these architectures, I need to run on RISC-V too because that's my opportunity. It's not because it's technically cool, it's because there's business value. And so what we've seen for, Android as an example, for the Android team to support RISC-V, we needed to first see volumes and enough customer demand to warrant that investment from the team. So those are the types of next era that we're ushering in, both in standards as well as in open source.
So as a reporter, I wouldn't be doing my job if I didn't ask the hard questions. So I got to put you on the spot here. Where does RISC-V need to move to that you aren't in yet, that you haven't started exploring yet?
RISC-V has already made inches forward across the full compute domain. What we have yet to do is get to scale across all of those domains. So we are on the precipice of, going into data center, in laptops, and all the other devices. There are lots of predictions about RISC-V in HPC, RISC-V in cell phones, and when it will be the primary processor, when it will be all of the processors. A few years ago, I was talking to an analyst who said, more than 25% of all design starts include at least one RISC-V core. That was a few years ago. Last summer, I talked to him and I said, so what's the number now? And he told me, it's hard to find a design start that does not include at least one RISC-V core. So we are arriving at that design phase, and you're going to see us move very rapidly across that spectrum in the next few years.
So if I don't ask this next question, the secret cabal of tech journalists has to come and take me away. Let's talk about AI. I know RISC-V is heavily involved in a lot of AI projects, and I've talked to several companies here today that are leveraging RISC-V in their AI. What parts of the RISC-V standard are ideally suited into working with AI, and why is that so attractive?
So AI, as well as any other processing, has to do with how much design flexibility you can bring to that workload, and that's where RISC-V and its complete menu of different open extensions comes into play. But where folks can really find their competitive edge is in some of the reserved encoding space that you can use for your own proprietary extensions, your own proprietary or your secret sauce that makes your AI better than someone else's. But there are things that we're doing as base building blocks, like our vector and vector crypto and other pieces that we've been ratifying that allow for that new era of design freedom.
So as we get near the end of our time here, my favorite question to ask is the one I saved for last. And no, this is great because it makes you do all the work. And the question is, what didn't I think to ask you that's really contributing to the growth of RISC-V and the strength and everything that everybody should be knowing about, but they're not talking about enough yet?
So I think it's the strength of what you truly get from a collaborative community like this is that you're able to progress not only our shared mission, but you're able to say like, wow, look, there's 6 other people doing something I thought I had to go do by myself. Let's do that together, bang it out, and then go do the next cool, interesting thing together. You don't have collaboration at scale if you're working in a proprietary environment. In a proprietary environment, that's called development partner. That's a one-to-one relationship. When you have a one-to-many relationship, you actually reduce the level of risk that's in your business and technical strategy for taking a particular direction. So that collaboration and that contribution and developer bite and strength is something I think is often assumed and overlooked in a community like ours. It accelerates your individual traction as well as brings learning back into your organization that you wouldn't get any other way.
Well, folks, I think the message here is pretty clear. It's time to take a risk. 5.